여러분, 안녕! Welcome to Math with Miss Kim. In this video, we are going to get more practice using the distributive property. I noticed that the distributive property was a little tricky for us, so let's get more practice with this skill. As always, with these videos, make sure you have something to write on as well as something to write with. Here we go. So we see this problem, we have this 2 and then we have 3 plus 1 inside the parentheses. And if you are familiar with order of operations, you might solve this problem like so. You leave the 2 on the outside and you solve what's inside the parentheses first. 3 plus 1, that gets me 4. And then you multiply these together and get 8. Well, in this video, we are focusing on the skill of distributive property. So we're not going to do it this way. Instead, we want to focus on our keynote. And here's our keynote for this video. The distributive property lets you multiply a sum by multiplying each addend separately. And it's going to look something like this. So we have a number on the outside and you multiply each addend separately. So you see this arrow goes to the B or the first term. This arrow goes to the next term inside the parentheses. So again, you are multiplying each addend separately. And we have here A times B. And then you are adding it to A times C, because here it says, right, multiplying each addend separately, and then you add the product. So what does that mean for this problem? Well, the first thing I'm going to do, draw my little arrows like my example shows here. So I draw the arrow, the 2 to the 3, and I need to draw it to the 1. Okay? Then it says I can multiply each addend separately. So I have 2 times 3 and then we have 2 times 1. And then add the products together. So I add them together. Okay, well 2 times 3 gets me 6. Plus 2 times 1 gets me 2. And this also gets us 8. And you might be thinking, man, Miss Kim, that's a lot of steps when we could solve it easily like this. Well, we need to use the distributive property. And you will see why we are using the distributive property in the next example. So let's go ahead and take a look. Here we go. So now we have 8 is being multiplied by y plus 4. And again, here is our keynote. We are using the distributive property. It looks a little something like this. Well, the reason why we use the distributive property. So we use the distributive property because the 2 terms inside the parentheses can't be combined because they are not like terms. I don't know what y is, so I can't add y plus 4. So going back to that other example where we were able to add the 3 plus 1 and get 4, we can't do that here because they are not like terms. And what do I mean by like terms? Like terms are terms whose variables are the same. So here we have a y and we have a 4. They're different, so we can't combine them. So they are not like terms. I'll leave that here so that you have this definition of like terms. Okay? So because these are not like terms, we have to use the distributive property. All right? Well, remember, the distributive property lets you multiply a sum by multiplying each addend separately. So I'm going to first draw my arrows. The 8 goes to the y, and the 8 needs to go to the 4. So now we multiply 8 times y and then 8 times 4. Oops. We'll pretend that's blue. And it says you then add the product. So I add these together. Okay? Well, 8 times y is just 8y plus 8 times 4, that's 32. So we just simplified this into this expression of 8y plus 32 using the distributive property. So this up here and what we just got, these are equivalent expressions. Equivalent expressions are expressions that have the same value. So these two have the same value even though they may look a little different. So here's an example of two expressions that are equivalent. So these are equivalent expressions. We just simplified it using the distributive property. All right, so we need to get more practice. To get better at math, you need to practice. So let's go ahead and look at our next example. So now we have 2 is being multiplied to 5 plus g. Here's our keynote. We need to use a distributive property. Here's our little model of how to do it. Let's begin. So I'm looking here and I know I have to use the distributive property because inside the parentheses, I can't add 5 plus g because they are not like terms. So again, when they are not like terms and we can't combine them, we got to use a distributive property. So the first thing I'm going to do, draw my arrows. 2 needs to be multiplied to the 5 and 2 needs to also be multiplied to g. So let's go ahead and show that. 2 times 5. Then we have 2 times g. Okay, after I multiplied each added separately, I then add the products. 2 times 5, 10, plus 2 times g is just 2g. And we just simplified the expression up top using the distributive property. So the distributive property allows us to simplify equations when dealing with unknown values. So we just simplified it. And again, this expression up here and what we just got down here, those are equivalent expressions. They have the same value, even though they look a little different. All right, let's go ahead and look at another example. Here's our next example. We have 6 is being multiplied to y minus 3. And I know I need to use the distributive property here because the two terms inside the parentheses can't be combined because they are not like terms. So I need to use the distributive property. And the biggest difference on this example compared to the other ones is that instead of it being added here, it's being subtracted. We can still use the distributive property. So the first thing I'm going to do, draw my arrows. 6 needs to be multiplied to the y, and it needs to be multiplied to the 3. Make sure you multiply the outside number to all of the terms inside the parentheses. You have to multiply to every single term inside the parentheses. You can't just multiply it to the y. You have to also multiply it to the 3 in order for it to be an equivalent expression. So we have 6 is being multiplied to y. And now we have 6 being multiplied to 3. But hold up. Remember, this problem is a little different from the other problems. We have a subtraction problem this time. So instead of putting a plus sign in the middle, we're going to write subtraction. Okay, well 6 times y, that's 6y, minus 6 times 3, 18. And this is a simplified expression using the distributive property. All right, well, we have one last example that's different from the rest. So here we go. Oh man, we have this expression of 4xy plus 6xb. So many letters, so many things happening. I'm confused. Well, this lesson is all about the distributive property. So let's find a way to write this using the distributive property. And what we want to think of is, what do they have in common that I can take out? So I'm going to show you 3 ways you can write this expression using the distributive property. The first way, I think, what can I take out? Well, I ask myself, what do 4 and 6 have in common? 2, right? 2 times 2 gets me 4. 2 times 3 gets me 6. So let me take out a 2. So if I take out a 2, I ask myself, okay, what does 2 need to be multiplied to get to 4? 2. So this would be 2xy plus, what does 2 need to be multiplied to get to 6? 3. 3xb. And let me show you how I know that this is equivalent to this up top. I'm going to do the same thing that we did before. We're going to draw our arrows. I multiply them. This will get me 4xy plus 6xb. And this is the same as our original problem. So I'm going to highlight how we wrote it using the distributive property. Boom. Okay. Well, I said there are 3 ways to do this. So let me show you another way. So draw it right here. Okay. Similar to how we did this one where we asked, well, what do these have in common and what can I take out? I look here and I'm seeing, oh my goodness, both of them have the variable x. Let me take out the variable x. So I take out the variable x. That will leave me with 4y plus 6b. And you might be wondering, is that actually going to work? Well, let me show you, using the distributive property, how I know that this has the same value as this up top. Draw my arrows. X times 4y plus x times 6b. we get the same thing. We have 4xy plus 6xb. That's how I know that this is an equivalent expression to this up top. So we just showed two ways to write this using the distributive property. Let's do a third way. So similar to what we did over here, we asked, what do they both have in common? Well, we said they had a 2 in common and an x in common. So why don't I take out a 2 and an x? Take out a 2, take out an x, and that will leave me with 2y and 3b. So you might be wondering, whoa, this looks crazy. Well, let's prove it by using the distributive property to show that this has the same value as this up top. So again, distributive property, we need to make sure you multiply the outside number to all of the terms inside the parentheses. So I need to multiply this to here, this to here. 2x times 2y plus 2x times 3b, right? That'll leave me with 2x times 2y gets me 4xy plus 6xb. So we just showed a third way to write this expression using the distributive property. This one was complicated. This one had a lot of terms. Well, not a lot of terms. It had a lot of pieces and a lot of variables. So this example was just showing you how to use a distributive property with a complicated mixture that you can apply to simpler problems when you need to write equivalent expressions using the distributive property. So again, our keynote for today was distributive property lets you multiply a sum by multiplying each addendum separately and then add the products. And this was the way you did it. You have this number outside and you multiply it to each addendum separately. So A times B, A times C. And then you add them together. And this will get you an equivalent expression. Well, thank you for joining me today. I'll see you next time. 안녕!